This is video 5 in looking at problems related to the binomial expansion. This problem says what we want to find the term in x to the fourth, in other words, the term that has x to the fourth in it, in this expansion. So notice that this one's a little bit different because we have a binomial raised to a power. So what we have right here is a binomial raised to a power, but then that's going to be multiplied times x to the third. And remember, order of operations tells us you do powers first, so you would do this first, and then you would distribute the x to the third. So I want you to think about what that would look like. If we just want the term in x to the fourth, we don't have to expand the entire binomial out. We just have to look for one particular term in this case. So think about what this x to the fourth times the quantity x to the third, times the quantity 3x minus 2 to the fourth would look like. We would still have the x to the third out in front, and then we would have this expansion, and the expansion would start with some power of x to the fourth. All right, we know that that's our first power of x. And then we'd have something times x to the third, and then something times x squared, something times x, plus our constant at the end. All right, and then what we would do is we would distribute. So we would take this times this, this times this, this times this. So I want you to notice that this x to the third times x to the fourth would give us a term in x to the seventh, and we don't want that. We only care about the one that is going to end up with being x to the fourth, and that's going to come from taking the x to the third times this term over here. So what we're really interested in this problem is the term in x in the expansion of this binomial. So I'm just going to make note of that. We want the term in x, or in other words, the term that has an x in it, in the expansion of 3x minus 2 to the fourth. And so what we'll do is very similar to what we did in the last problem, is we will write the general term. So the general term will be 4 choose r times, our first term is 3x, so 3x to the 4 minus r power, and you can go back and double check my formula based on the binomial theorem, and then we'll have, think of this as plus a negative, so then we have negative 2 to the r power. Now this one, we don't have to do quite as much work as we did on the last one, because notice that the x only comes from this factor, right? And there are no x's here, there are no x's here, it only comes from here, and we want the term in x. In other words, we want the term that's x to the first. Well, how would we make that happen? Well, by making this exponent be a 1, because then we would have 3x to the first, and that would give us x to the first. So how do we make that be a 1? So therefore, we want 4 minus r to equal 1. That means that r has to be 3. So that means that our term in x to the first is going to be 4 choose 3 times 3x to the 4 minus 3, which is to the first, negative 2 to the third power. So this gives us, and again, I'll let you double check these. 4 to the third is just 4 times, and then 3x to the first is just 3x times negative 8. So this is negative 96x. But remember, we wanted the term in x to the fourth. So what we have to think about is that this term right here is going to be negative, this is going to be squared, negative 96x is what this term will be. And so when I multiply the x to the third times the negative 96x, that's going to give me negative 96x to the fourth. So we can say, therefore, the term in x to the fourth is x to the third times negative 96x, which is negative 96x to the fourth.